Awesome. Looks like we got our whole panel set up. So I'm really excited to introduce Lauren Steele, who's an associate research specialist at Metropolitan and a data scientist as well. So always great to have a fellow water data scientist and key partner from Metropolitan as part of the data collaborative, and really works with a passion to turn data into policy. And her work focuses on the science and economics of urban and agricultural water use in the Western US. She has her master's from UC Santa Barbara, where she participated in the Sustainable Water Markets program at the Bren School of Environmental Science and Management. So got a great background and very talented data scientist at Metropolitan. So really excited to have her moderate this next panel. So I'll turn it over to Lauren. Thanks.
All right, thank you so much, Drew, and good morning, everyone. This is my first Water Solutions Conference and my 5th California Water Data Summit. Traditionally at the Data Summit, we've focused on the important work of improving urban water management, but we haven't talked very much about agricultural and environmental water use, which make up the bulk of water use in California and contribute greatly to our economy. At the same time, partnerships between urban and agricultural agencies are an increasingly important part of how we manage water in the West. So I'd like to take a moment, Elena, if we have the poll available, pop it up on screen. If not, no worries. And wanted to take just a moment to acknowledge that although a lot of us come from the urban water and tech fields, many of us are working with growers and thinking about the ways that we can farm more productively with the increasingly limited water resources that we have. Most of the water that humans use in California goes towards agriculture, we know this, and yet in many cases, our understanding of how much water is used and where is quite poor. And I know from my own work with growers in the Palo Verde Valley that in the ag world, even just measuring the amount of water that's applied to a field can be a real challenge. Unlike in the urban world, we don't usually have precision water meters, and the diversity of agriculture in our state means there's just no one-size-fits-all solution. So in this panel, we'll be showcasing 3 exciting projects that are addressing this challenge. One from an innovative tech company that's working to help farmers manage their water better. One from a state agency that's thinking about how to manage the enormous amount of groundwater data that will be reported under California's Sustainable Groundwater Management Act. And one from a very diverse group of organizations that are coming together to democratize access to evapotranspiration data measured by satellite. We are going to be taking questions. Please use the Zoom Q&A to send them in, and we'll get to them at the very end of the session. So our first speaker is Robin Grimm. Robin is the Senior Manager for Water Information Systems at the Environmental Defense Fund. Robin's work at EDF is primarily focused on filling critical water information gaps to enable more sustainable land and water management practices across the Western US. And I'll just tell you, Robin is currently working on a project that I honestly believe is going to revolutionize water management in the Western US. The timing here could not be better because after several years of work, her team is about to take this project live to the public. And you're going to hear about this project right now. So Robin, I'm very pleased you could join us, and welcome to the panel.
Thanks so much, Lauren, for a very kind and also intimidating introduction. I'm really happy to be able to be here and talk with all of you today. Am I able to see, real quick, sorry, the slides as they're being shown, or do you already have the slides up? Sorry, just a technical question.
Might take us just a moment to get the slides up.
Okay. So as Lauren did mention, I'm going to be talking about a project called OpenET, which I think a fair number of you may be already familiar with. The opening slide here, when it does come up, does show some of the other co-leads of the project. And as Lauren mentioned, it is quite the collaborative effort, and even the folks represented here are not the total of the team that is OpenET, but these are the folks I'm working closely with on project management. So And you can go ahead to the next slide. I'll talk a little bit about the broader collaborative in further slides, but I did want to start with just a quick definition for those who aren't aware, aren't familiar. The ET in OpenET stands for evapotranspiration, and it's a really important part of the water budget to understand. If you think about water flowing over a landscape, it's going to do one of four things: either evaporate off of the soil or water delivery system, transpire through plant leaves after being used to grow, or it'll recharge the underlying groundwater basin or flow back into a nearby stream or delivery canal. And for that reason, ET, that combination of evaporation and transpiration, really represents that critical portion of the water budget that is lost for reuse in a local system. So it can be a very good metric for consumptive water use in that way, with a few exceptions. And so, you know, every day, thousands of people across the West are making decisions about water. And as Lauren mentions, a lot of times they're often having to work with either outdated or inconsistent information on ET, or the information is expensive, or they just don't have access to the information at all. And so next slide, please. OpenET is at its most basic form, focused on solving for that gap. We're bringing together the scientific community behind a host of different approaches that have been used to estimate ET in the past, putting them all on one team together, using best available science to reduce some of the noise and confusion around the data that's existed, and at its most basic form, make consistent near real-time field scale estimates of ET accessible via web page for the entire Western US with a latency of only about 4 to 6 weeks. And as Lauren mentioned, sometime early next year, anyone's going to be able to go onto a website that will look much like the image that you see on your screen here and zoom in on a geographic region and get near real-time ET data for that geography. Next slide. So there's a host of reasons that we're excited about this technology. There's a lot of really exciting potential applications. First and foremost is to allow for the development of more realistic water budgets that drive decisions about water allocations and use in a basin or watershed. It also enables local water managers to develop incentive-driven conservation programs that are driven by real data that can then properly credit folks who have invested in and made real changes in terms of water conservation. The ability to track water use in near real time significantly reduces transaction costs for water trading programs. And then finally, at that really local field scale, there's the potential for ET data to be incorporated into ranch management or irrigation scheduling software that can help increase on-farm efficiencies. Next slide. So for us, you know, there's that sort of top goal, the really intuitive one, right? That what we're trying to do here is provide this reliable ET data for any area within the Western US. And critical for us is that represents shared access to trusted data, both for the people who are making policy decisions about water, but also for those who are affected by them and sort of working in a more day-to-day sense on water management. But we know that doesn't happen unless there's actual trust in the validity of the data and the information provided by the platform by users at all scales. And so that's an equally important goal for us and something we've been really focused on from the outset of this project. And finally, we believe that if the first two of those goals are met, then a variety of sustainable resource management practices can be enabled at a scale not really seen before. Next slide. So we've worked really hard to build that trust and ensure the quality of the platform in sort of two ways, both of which really focus on collaboration. So we've ensured that this is a collaborative undertaking, both from the scientific perspective and also from the end use perspective. On the end use side, it's been a truly user-driven effort from day one. A big part of that approach that we've taken is this use case portfolio that we've formed across the Western US. As you can see on the map there, it really covers a host of potential applications for ET data, as well as a diversity of potential users that are operating at varying scales of decision making. So we tried as best we could to capture a lot of the diversity in the types of communities and folks that are going to end up using this platform. And I'll talk in a little bit more detail about some of those California use cases on a further slide. So at this point, we can just keep going to the next slide. We did realize that it's impossible to capture all of the perspectives that we wanted to with that use case portfolio because those use case studies take a bit more time and capacity. So we also developed these working groups for California and the Colorado River Basin to ensure that we receive input from a broader set of perspectives. So the working group members have been involved from the very beginning at helping us develop a needs requirement type report that underlied the development of the platform. They've been attending quarterly webinars where we sort of pose big questions about directions that the OpenET team is taking. And we've had a couple of annual workshops, and our use case partners have been involved in those as well. And all of those efforts have really helped guide the development of this tool and have been really critical for us. And so we're super grateful. If there's some of you in the audience are part of our working group or use case partnerships, we're really incredibly grateful for all the time you've spent with us. Next slide. As I alluded to earlier, OpenET has also tried to build a really strong scientific team responsible for the development of the platform and incorporate a lot of the methodologies that folks that have worked with ET data in the past are already somewhat familiar with. So you can see the models that we're incorporating onto the platform on this slide here. If you go to the next slide, I think another component to this is not just incorporating those models, but actually the team itself. So the strength and collaborative nature of the scientific community that stands behind OpenET has been one of the really rewarding parts about getting to work on this project. The team includes approximately 30 researchers and practitioners from NASA, Desert Research Institute, USDA, USGS, et cetera. They're all listed up there, with expertise varying from, user-driven web development, satellite-based estimation and evapotranspiration, cloud computing, et cetera. And I'd say more important even than the credentials of any of these contributors is the degree to which they've been working so well together and learning from one another in this collaborative environment. A lot of the team members agree and are excited to be sort of starting down the road of writing papers about the degree to which just the state of the science itself has been advanced by this effort. And one of the things we're always so grateful for is that our funders understood from the outset that the normal model of kind of funding this type of effort that really incentivizes competition and sort of forces folks to make the case that their one way is better than the others works to a certain point and is really great for driving innovation, but at some point pulling the community together again to help sort of reduce the noise and all the data and bring some common understanding to it is also really critical. So we're really thankful that we've had the opportunity to do that with this project. So next slide. So I tried to kind of give the overview there of what we're up to. I'm going to go into a few of our recent updates, and as I mentioned, also briefly talk about a few of the California use cases. And I know, Lauren, that we're going to take questions at the end, so I'll save the time for questions for them. So we can go on to the next slide. One of the advantages to the collaborative team behind OpenET is that we're able to now conduct maybe the largest intercomparison study of satellite-based ET methods ever conducted across the Western US. We're primarily utilizing ground-based measurement of ET at flux towers for that intercomparison, but we'll also be comparing results to some groundwater pumping records and doing a few comparisons at the watershed scale. Go to the next slide. And the great news is that for irrigated agriculture, many of the preliminary results are so far really promising. The approach that the team is taking is to compare the models against about, I think, 50 to 70 sites in a first initial comparison, allow the teams then to go back and make modifications as they learn from that first intercomparison effort, and then run the models, compare them against a whole different set of sites in a second comparison. Once that has been done, you can see it, for example, in this slide, we are learning that in some cases for particular land cover types, certain models don't do as well as the others. And so if once the final comparison is done, we're still seeing patterns like that, then that will factor into the way the ensemble value is calculated. Right now, we're still just calculating the ensemble as an average or a mean of all the models, but it is likely going to be the case that sort of per land cover type, some models may get dropped. And especially, these results look great. There are some, for shrublands and some of the other non-agricultural land use types, there's still some work to do. And so especially for some of those, it's likely that it'll be a subset of the stronger models that are utilized for that ensemble value. Next slide. So we're also working to ensure that the access to this data is not just via that website, that there's also an application programming interface route so that folks can in a computer-to-computer more operational way access the data. And we know that that's important for a variety of reasons: state agency use, incorporation into irrigation management tools, and water trading. And we're really close actually to having an initial version of that some of our partners will be able to start testing with us and iterating on. So we're excited about that. Next slide. I was told by some of my NASA and DRI partners that it'd be important to make the point that there is multiple ways that folks will be able to access that API. I do not have the expertise to interpret the language on this slide, so hopefully there aren't too many questions on this particular point, but they are, again, working really hard to ensure that there are quite a few pathways to the data. I see, Lauren, I have 1 more minute, so I'll try and go quickly through these use cases, apologies. So the first use case I wanted to highlight was Rosedale Rio Bravo. We've been working with Sitka and others to help them, they sit in the Kern, I should say, they sit in the Kern subbasin and are, looking for ways to manage through and respond to Sigma. And one of the ways that Rosedale is looking at doing that is to develop this accounting and eventually maybe a trading platform for their basin there. And so that's something that would be really difficult and expensive to do without OpenET. OpenET is basically providing the water use data that's being incorporated into that platform. Next slide. We're also working with the State Water Board and landowners and agencies in the Delta to help develop, sorry, I think, so we should go to the next slide quickly here. An alternative plan of compliance for SB 88 in the Delta, where OpenET could serve as an initial rebuttable estimate that folks could use to report with, rather than having to spend money that would otherwise be needed for all of the meters to comply with SB 88 in the Delta. So we're excited about that one moving along and having some traction there. And then finally, next slide. I mentioned before, we are also working hard to ensure that data from OpenET can be used to help improve irrigation scheduling and farm and ranch management tools. And there's some applications, partnerships that we have with the Almond Board, and also working with Michael Kahn of UC Cooperative Extension on the development of a crop manage tool. And since I'm short on time, I will just stop there. And if there's questions about this particular application, I can speak to it in more detail in the question and answer section.
Awesome. Thanks, Robin. I know it's hard to go through everything involved in OpenET in just 12 minutes, but that was a great interview. And if anyone has specific questions, feel free to send them in or go check out the OpenET website or just email Robin. And I've been lucky enough to try out the beta version of OpenET, and wow, it is a beautiful and powerful tool. And I'm quite excited to get my hands on the full version of it when it's released next year. So moving to our second speaker, we just heard about the importance of growers having access to good data on their own water use. Our next speaker is Kevin France, who has been pioneering another approach to this. Kevin is the CEO of Swim Systems, which is a really quite innovative company that I've had the pleasure of working with, as they've helped my team at Metropolitan with the challenge of managing our farmlands. Under Kevin's leadership, Swim has been recognized as a top 25 ag tech company globally by Forbes for 2 consecutive years. And he's led a team of professionals that has grown the company's operations and partnerships with major agricultural stakeholders, including a one-of-a-kind strategic development agreement with the Western Growers Association. He's been involved in many other agricultural development projects, which I don't have time to go into here, but you should go read his full bio because it's quite impressive. Kevin, I hope you're staying cool up there in Colorado, and welcome to the panel.
Hey, thank you, Lauren. I appreciate the introduction. I'm not sure how much of that's, maybe I put too much puff into that, but I guess I appreciate that. It sounds better than it is, I guess, but much appreciated. Appreciate the invite and appreciate the opportunity to chat a little bit. And Robin, I want to thank you. You gave me a great introduction on ET, consumption, satellite data. I've got some slides in there, but I'll be able to kind of jump around that a little bit, maybe not spend as much time on it. Quite complimentary. Robin, you know, we're happy to be contributing as well on the OpenET. We look at that as a solid source of consumptive use data. So we're hoping to be able to explore that a little bit more here as you guys get your API going. It's great technology. So I appreciate that. So with that, Lauren, thank you. I'm CEO of SWIM. We are on-farm water accountants. And I guess let's go and go to the next slide. When I was asked to speak a little bit about California data and water and sum it all put together in my head, I was trying to come up with a quote that would resonate with the group. And as normal, I wasn't so eloquent that I could come up with any quote that I would say that would be worth a hoot. But I did remember a quote that was shared with me about 2 years ago from someone else who's significantly smarter. Many of you know him, Dave Puglia, CEO now of Western Growers. We were having lunch in Bakersfield about 2 years ago after we met a couple of growers about use of SWIM. And he made this comment almost verbatim: an argument over water is an argument over data. It's really, I think he actually said an argument of water over water is really an argument over data. And I sat there and I pondered that for a second. I said, what do you mean, Dave? And he said, you know, with the issues that we have, whether it's sigma around groundwater, surface water deliveries, drought, continued reduction and retraction of water use, without having that data, you're at a loss. It's all about having the data, having usable data, data that can be used to make decisions, but that also can back your position, whether you're a grower, a series of growers, a co-op, or even a GSA or a district. It's all about the data. So that quote resonated with me. Next slide, Lauren, if you would. Thank you. And with that, I want to talk a little bit about what we're doing. We get a little more granular. So what is an on-farm water accountant? Normally in a presentation, I'd ask everyone to raise their hands, and those that have an accounting or financial background to step up and admit themselves. But these days, I think being a CPA is almost as bad as being an attorney. So no one may actually raise their hand, but I couldn't see them on the screen anyway. So I'll just assume a couple of you did. Those that have that accounting background, I think this will resonate. We're monitoring water usage the same way your CPA or accountant would be tracking your financial records. And so if you ask your accountant to balance one side of the budget, you know, all of your cash inflows to your account, that would give you some visibility to your accounts, good information, useful, can make decisions, but wouldn't give you a full bank account balance. You'd have a lot of holes in the mix, a lot of assumptions you're making. On the flip side of that, so if you were looking at all your outflows, even if you knew where all your money went, sub-accounts of expenses, again, that gives you some good insight, very important information, better than nothing, and significantly better than some of the data that's in bits and pieces out there. But to balance an actual water budget, we believe you have to have both sides of that entry, that journal entry, to use a financial term. And that's what we do. So we mesh the delivery and consumption reports together. We do use flow data to the field. We get that through a multitude of ways. And then we use consumption data. We use a combination of weather data and satellite data by field. And those reports are audited by our team because they always have holes in them. And so we have to fill in the gaps, and then we provide an audited report the same way your CPA would at the end of the season. So when you mesh delivery and consumption together, you get one more important key component that we believe is important. You take consumption divided into delivery, and you get a percentage. We call it effectively a consumptive use fraction, or the direct driver to irrigation efficiency, right? So if you use SWIM for 6 months and you find that you're 55% efficient, that means 55% of your water is going to crop growth, ET, consumptive use, to keep it simple, and the rest of the water is going somewhere else. We can help you track where that's going and create improvements based off that baseline. Lauren, next slide, please. Appreciate it. So we spent about 5.5 years with USDA. Our first patent was co-developed with them on this process, and then we created 2 other patents behind that. But this thing's vetted. It was vetted in the field. We used a couple of researchers at Colorado State, Utah State, and a couple of folks from Fresno State under USDA's direction to write papers on it, to vet the technology. So this is something that's been well vetted. Lauren, next slide, please. And as Lauren so eloquently mentioned, Western Growers came behind us on this a while ago when they saw the value proposition we were exploring. 10-year strategic development agreement. We have board members on from Western Growers, and of course, in the interest of full disclosure, they've made a pretty sizable investment in us. Their position is their growers, representing 60% of the fresh produce in California by scale, need a tool to understand their water usage. It's as simple as that. And if you ask them that, I'm sure they would expound, but that's the bottom line. Lauren, next slide, please. So to my knowledge, we're the only company that fully accounts for the water balance. And if there's one out there, I'd love to hear about them, but I haven't been able to track them down. We provide a statement of water use. So think about your financial or your investment accounts. It's accurate, it's auditable, it's automated, and it's trusted, and it's based on a series of data inputs that we can rely on. Next slide. Sorry, I have to keep saying that, Lauren. What is a water balance? Well, it's keeping track of how much water enters and leaves your field during a season. It's very similar to balancing the checkbook. That's a good analogy. Okay, I'll just put my hand up here the next slide because we're going to blow through a couple of these quickly. What do we do with the water balance? Lots of things. We can measure best irrigation practices. We can flag irrigation conditions that are up or under where they need to be. Determine when to irrigate so we can, a lot of the stuff that you heard there with Robin, that's very similar in this case. Monitor water use for regulatory agencies. We're starting now to run some pilots on actually direct reporting diversion flows in some cases. So that's moving along. The more we can take the water accounting out of the grower's hands, who really wants to grow, we're told by our growers, the happier they are. There's agronomic purposes for a water balance and also benchmarking, swim certification, which we'll talk about later. We'll go to the next slide. Inputs for a water balance, evapotranspiration, biggie. Robin mentioned that in her section. We're also gathering irrigation deliveries, rainfall, field crop size, crop planting, and harvest date. That lets us kind of get more granular, if you will, in the process. And one of the big things, you know, I asked myself here when you were asking me, Lauren, to speak about how do we make this data open? How do we make it accessible? Because we're dealing with data that growers, in some cases, don't want released to the general public, right? It's sensitive information. So how do we do that? So SWIM's working on ways to use that aggregated, anonymized data for the benefit of our growers in a way it doesn't identify them, but allows them to benefit from having this type of water use data in addition to some of the items that I've mentioned thus far. I don't know if you guys can see on my screen here, a little certification stamp on a pretend orange. Won't rot, that's why I have it in my office. We have growers that are using it for buyer certification. So they're looking for better payments. If they're crop commodity, they're looking to them, to those end buyers within the supply chain to offer better rates, because then those end buyers can say that their water is created or their product is created with less water. So those sorts of things. So we launched the SWIM certification about 90 days ago. It has picked up significant traction, talking to a lot of folks now on the buy and sell side of the supply chain that wish to push this forward because it's an important component. Lauren? So that's one way we can use that aggregated data, if that makes sense. Accounting for an agricultural water balance is super complex, and I'm not going to go through all the details now. We could write a book on it. I think we actually have written 2 papers on it so far, but we try to keep it simple because the other thing is water use data. The biggest complaint we hear from growers is they have all these data sets and they don't know what to do with it. It becomes a problem. So you have surface and groundwater, making the available water available to the grower, then it goes to the farm and the field. And we have to deal with the applied and consumed component. Go ahead, Lauren. It's a complex model, and this is how we do it. We gather the pump and gate data, weather and satellite data integrated together. We have field and crop data into the system, and then we use crop production data, and we can provide these reports to the farm, district, GSA, and or the state. Go ahead, Lauren. Thank you. All starts with monitoring and accounting at a field level. So we take it as granular as we can get it, in some cases block level. All deliveries are monitored, whether it's an open channel or pipe or sprinkler. And then we use a combination of satellite and weather data interconnected to estimate consumption on a per field basis. We aggregate those together, and that's how we get the water balance. Go ahead, Lauren. I'm going to have you hit the space bar 3 times because this is a slow slide. I like to get you to think about SWIM umbrella. We have infrastructure, pipe, delivery of the plumbing for water. You then have sensors on top of that. And then you have this umbrella that ties into the SWIM platform. And then SWIM gathers this data, multi-dimensional, and puts it into the grower's hands in an easy to use method. Go ahead, Lauren. Connects with both third-party equipment and our own equipment. So we're data and hardware agnostic. Go ahead, Lauren. And then we produce these delivery reports. They're weekly, and then at the end of the season, our growers are able to get audited reports. It has every delivery. Go ahead, Lauren, hit the next one if you would. Delivery, consumption, and then you have a journal entry, just like you'd see on your bank account, every event showing the water in and the balance. Go ahead. This is a great graph. If you look at it, the light green line is the target. The grower sees their delivery, which is in blue, And then the dark green is consumption. And their whole goal is to narrow that line. They have both data sets and they're narrowing the line. They're freeing up consumptive use. And we can tell them to dollars and to volume what that means to their operation. So it's like playing a game. It's like a widget app to the grower. Go ahead, Lauren. Then we put it into a dashboard. We'll go and flip to the next slide. So this is a kind of a visual, average dashboard setup, although it's fully customizable. You have a field. You have that same water balance graph that's scalable here. So you can make it bigger on your screen and see details. Every flow point, we have data, and then you'll notice it's QA/QC, so it's quality checked throughout the season. It always lags the data, but you can see where your data's been corrected and where it needs work and where it's already been cleared. And go ahead, Lauren, hit the next slide if you would. Growers can set alarms. So this red bar shows that this irrigation location is in alarm. It's under budget. So the grower doesn't want to be down here. They don't want to be over here. They want to be right in the middle. And they get a text message, email, some kind of notification through the system at their choice. Go ahead and hit the next slide, if you would. Same on the water balance widget. Delivery, consumption. They can set their details on from and to dates, and then they can set alarms behind it too. So it's very easy to understand. Go ahead and hit the next slide, if you would. And then the grower can customize their widget. So we give the grower exactly what they need. No more, no less. And then they customize the widgets on their dashboard in a way that makes sense to them. Go ahead, Lauren. We've got about a minute left here. Robin, thank you for talking about consumption. So I'm not going to spend a lot of time here, but I will just mention we do use weather data, our own weather station network, and CMIS data to estimate crop evapotranspiration based off of what the engineers say it should be, right? And then on average, 8 to 16 days, we have a satellite fly over that calibrates that curve. Lauren, one more slide if you would. So a good way to visualize it is we're developing this crop curve on weather data, estimate of what the field should be consuming, and then roughly every 8 days, we get an image. If it's above or below that line, we adjust the curve. So having both of those sources of data allows us to get more granular and to the field level. Lauren, last slide, I think. I'm going to leave you with this slide. And the reason why is because looking at just satellite or weather data, we believe looking at both is helpful. Satellite obviously gives you an actual point in time measurement at a particular point in time, but that's what it does. And there's lots of spaces in between. So we believe by using weather data and satellite data, that gets us a little bit more toward what's happening in the field. And this is a good example. ETC here is in blue. This is weather station data. So this is what the crop should be consuming, but then this is what the satellite at this particular point told us should be happening. So there's a whole lot of blue here in this graph that we believe the crop should have been using, but if we weren't using satellite data, we would have missed. And that can show up in a crop water budget. That could show up in a bill. So we believe that using both of those sources is critical. More data comprised and compared against is a good place to be. If you can wrap up the slide, I'll finish up by saying, because I know I'm getting over time on this, is how do you use this data openly? Our biggest challenge with growers is not releasing proprietary data. They're concerned about it. And water use data, as you can imagine, could be a big talking point for them. But using that aggregated anonymized data the same way Google does on my data, Google has accounts with me. They anonymize it. They use it for benchmarking. We can use it for benchmarking, creating irrigation efficiency benchmarks that they can utilize to see what their friends are doing within the region. It can be used to back the trading platform. You have to have good solid data. Robin alluded to that also in her presentation. There's ways you can use that aggregated data that doesn't put the grower at risk, and that's our goal. And with that, I appreciate the time, Lauren. Thanks so much, and thanks to the group for your attention.
All right, thank you so much, Kevin. I've had the chance to look at a lot of SWIMS data over the last 3 years, and it really is incredibly cool to be able to see individual irrigation events in high resolution. It's giving my team a lot of really good perspective on irrigation behaviors and how you grow different types of crops and different kinds of patterns. So it's really an incredible data set. So we've just heard how using ET in conjunction with sensor-based irrigation flow measurement, can be very powerful when those two things are combined. But now we're going to hear about groundwater pumping and the California Sustainable Groundwater Management Act, or SGMA. Our final speaker is Brent Vanderberg. Brent is a senior geologist specialist at the State Water Resources Control Board, which is one of the agencies that will be a regulator under the Sustainable Groundwater Management Act. Brent currently serves as the Data and Technology Coordinator for the Division of Water Rights, where he oversees development of multiple new Water Board regulatory data reporting platforms. From 2008 to 2014, Brent worked in the Fresno office at the Regional Water Quality Control Boards, leading the effort to develop and implement the Tulare Lake Basin Irrigated Lands Regulatory Program orders. And he joined the Water Board SGMA team in 2015, where he led the development of a GIS-based regulatory data reporting platform, which he's going to tell you about today. I'm very excited to hear from Brent. I first met him over dinner at a conference, and he impressed me with what a smart guy he is. He's very passionate about the work he's doing, and I'm very excited to hear from him now. So welcome, Brent.
Thank you, Lauren, for those kind words. Brent Vanderberg, State Water Resources Control Board. We're going to take a pretty quick jaunt through a software platform that we built to help us implement the State Water Board's portion of the Sustainable Groundwater Management Act. Now, we don't have time to go into the details, but effectively this is referred to, the State Board's piece of SGMA is referred to as the backstop, and it's what occurs if the local level is unable, unwilling, or somehow fails to manage its own water. This is not for the GSAs, it is for the State Water Board under SGMA and was designed specifically for the State Water Board. Next slide. We'll breeze through the narrative stuff because I really want to show you the platform. We won't look at all of the different system functions, but we'll look at the primary ones, which are to collect groundwater information from probationary, unmanaged, or otherwise unprepared extractor. A lot of the times the State Board will likely be entering into a basin where there are data gaps. We saw a quote earlier that when you're talking about data, or you're talking about water, you're talking about data. And one of the ways that I think personally that groundwater sustainability agencies might get in trouble is not really thinking about the data piece in a comprehensive way. And so what we tried to do as a backstop is think through what are the bare minimum components needed, what are the bare minimum data elements needed to actually implement, say, numerical or simulation models. And so we developed this software platform called GEARS. It's an online reporting platform. It basically was intended to reduce reporting burden. We know that paper reporting has gone by the wayside and we needed to rethink things. So we really focused on how can we use a new software platform to use existing information in GIS layers to pre-populate the report for the reporter. For example, and we'll show this in a second, items like the public land survey section are often required, but can be very difficult for reporters to find or to even know what that is. Under the backstop, we'll have every sort of reporter imaginable. And to make things easier, we did things like put a PLSS layer into GEARS so that that field is populated for the reporter. That's just one example of trying to streamline reporting, improve data quality, and really help the local level get back into a local level condition in that basin, which is required by SGMA. GEARS was also designed as a cloud system, and that's just important for, it's a Water Data Summit for the technologists because we don't know what our reporting volume is going to be at any given moment under the backstop. Throughout the next 20 years, it could range from 0 the whole time to 0 to thousands to tens of thousands back to 0. We won't know. And so to adapt to that, we designed a system that works in a cloud, scalable, load-balanced architecture so that the system only operates according to the resources that it needs for that user base. As users increase, costs increase proportionately. And I think that's really a powerful concept for fee recovery under SGMA. These are the three primary users of GEARS that we built GEARS for. The groundwater extractors themselves, that's the main user. The system is designed to focus on that specific user. We added functionality to allow agents or consultants to report for groundwater extractors. This is a reality. As Lauren mentioned, I'm from Fresno, and when I was working in the ag program, I saw a lot of engineering firms and consultants that were reporting for growers, and we thought, hey, let's get a double handshake it's a technical term meaning if a grower or an agricultural interest or whoever's pumping water, whoever they might be, wants to have a consultant report for them, allow GEARS to establish that relationship and keep track of who's in charge of what. So it helps us manage changes of ownership, large consulting firms that are working for the growers or for anybody that's involved in SGMA. And the last user is us at the State Water Board, our staff. When we have hundreds of reports, manual review is a little bit easier. When you know how many reports you have to review, like say in our dairy program or something, we know there's a certain amount of dairies, you can schedule it. But when we're collecting what could be tens of thousands of reports, we built in interfaces for our own staff to be able to query the data within GEARS in any direction, spatially, through a normal structured query, like just a search for a term, and we'll try to show those in a second. Next slide. Next slide. We'll move quick. Okay, so here's the primary functions of GEARS before we look at it. The first one, first and foremost, is to allow the groundwater extractors to plot and save their wells in a GIS framework so that the groundwater data are attached to that GIS framework and are therefore spatiotemporally accurate and useful. Big mouthful. All it means is we need time and space attached to these groundwater wells. When the reported volumes are reported, we need to know when, how much in a GIS framework. It's important for most natural science natural resource management. Number two, collect monthly groundwater use volumes. That's, of course, that's statutory. It's in SGMA, says we will be doing that. Third one's create PDF reports of the information. This is a flip on the normal create the report and submit. It's more now submit information to a system that then creates a PDF on the back end that symbolizes a report. Still reporting, just a newer method, more streamlined. The fourth one is just allowing individuals to access the information. That's easy to understand. We want them to go to one spot with a login and a password, and that's it. And the whole record's there. The whole whatever, if it's correspondence with the board, if it's the groundwater extraction reports, which we'll show in a second, all of it's right there, easy to access. The last two, 5 and 6, are for the staff. We'll show in a sec. We built platforms that not only help us organize large numbers of reporters, but also the physical billing and pieces of mail associated with it. When you look at SGMA from a statewide perspective or backstop perspective, we may be issuing any known numbers of letters to any place in the state. And again, in small volumes, it's easy to manage, but it does get kind of squirrely at large volumes. So we built in mail tracking into GEARS. So GEARS is aware of where the board has sent letters and actions that have been taken in the system following the sending of those letters. Next slide. Okay, so this is GEARS. This is what an extractor will see once they've plotted their actual well in place of use or parcel of use. I'm using my alma mater, Fresno State University right there. That's the science building where the little dot is. And what this just represents is what someone might see if they came into GEARS and had already plotted their well. You get a map to the left and you have a dashboard to the right. The dashboard to the right is your navigation pane, and then you'll see in a second becomes your reporting panel. So that's the general user interface and outline. There's 4 functions in the extractor dashboard: file your report, manage your wells and places of use. Perhaps you have new wells, need to change things. You can do that there. Access your documents, as I stated earlier, and then your boring account management stuff like changing your password. So now let's actually plot a well and go through the reporting process pretty quick here. Next slide. So here we have just a general pond. There's some sand trap or sand tanks to the bottom right-hand side, to the right-hand side of the pond, and there's a little dot. Next slide. That change represents clicking on the map and plotting your well. You can see in the bottom right-hand side, the longitude and latitude are provided in decimal degree. That happens automatically. You can also do it the other way. You can input longitude and latitude, and it'll plot the dot. Wells can only be plotted from certain scales to ensure spatial accuracy of the well. And you get a lot of, like, this isn't in the slide, but there's a lot of checks. Are you sure? GEARS also does a number of other things, like asks, hey, you know, there's another well right here. Are you sure this isn't that well? It can also say, hey, you know, you already have a well on this parcel. You're going to plot another one, not in the same place. Those aren't the same, right? So it helps clean up the understanding of where wells are. Next slide. This is the same shot, but the remainder of the input panel to the right, where you can start to see some of the details that the groundwater extractor would put into the panel, like maximum production of the well, the year that pumping began, the total depth of the well, which is absolutely critical if we're going to do any sort of 3-dimensional numerical or simulation modeling, and then topmost and bottommost screened interval or intervals, and then the casing diameter. Again, back to the absolute bare minimum data elements necessary to use whatever model we choose, say ModFlow or whatever, to allow those spatial bins. Next slide. All right, so you can't plot a well without a parcel where you're using the water. GEARS won't allow it. Every well must have a parcel or parcels. It's a one-to-many data relationship. On the right-hand side, it's very similar to the well. We're entering details about the parcel itself now. It's very simple. You just name it something so you know what it's called, and then you just select your purpose of use. Purposes of use are conditional and can change. Like if you select agriculture, other fields will pop up. Next slide. This is what you get when you're done. And you can look, plotting your well in your parcel of use. You can look in the upper right-hand corner and see that there's a bunch of details that were not asked for that are now populated. For example, that PLSS that I had mentioned, the big complicated long string of numbers, or the actual name and groundwater basin pulled from the Bulletin 118 GIS layer so that that reporter knows what basin they're in. GEARS knows because it takes this geospatial coordinate and compares it with those layers, thereby streamlining reporting and taking people out of the weeds here with some of this stuff. It can be complicated. As we go down that list a little bit further, you can see we named the well and all those details that we put in are now static. Next slide. After the last slide, we committed to the system a geospatial file set, and we have a relational database set to that geospatial file set that contains tabular information. That's for the water data nerds out there. Now we have to plot we have to actually submit the extraction report. So you click the blue button, next slide, and you now will go into a 3-step process. This was intended to be able to be completed in under 60 seconds. Once you've plotted your well and place of use for one system, you should be able to streamline reporting. Here you select your water year. Next slide. By the way, GEARS is aware that you can do back reporting in GEARS. We'll see if we have time to talk about that, but you can report for prior years if you have to. This is where you select which well you want to report for. We saw the example well at my alma mater, and we just made that pond well, so we'll report for the pond well. Next slide. This is an extraction report. This is the extraction report, and actually there's only 3 simple steps. Next slide. The first step, one of the most important, is that there has to be a rationale for the water measurement. It's either a certified meter, and we provide help and other details in a hover over nearby of what that means, or unmetered or estimated. This is the bulk of, if you don't have a meter, you're doing unmetered or estimated, in which you download or you upload a file that explains how you conducted that measurement, just for evidence of what's going on. The rest is literally 12 numerical values, each representing the amount of water used for that month by that well. You can add comments if you like, save it for later, come back, or you can save and continue. Next slide. This is just an example that this map and report has been auto-produced. Actually, next slide. You get a summary, and this is where things get pretty fascinating, from at least I think. This is a summary page of what we just did. Pretty soon it's going to make the actual PDF report, but notice that 1, it summed up the water use, and 2, it calculated the fee. This is interesting because depending on where you are in California, there's different fee schedules for you, depending if you're a probationary basin, unmanaged, and right now we don't really have any of them, so it's sort of hypothetical, but nonetheless, SGMA requires us to do these things. So next slide. This is an example of our fee schedule. Pull out your monocle if you want to see what that says. But basically what it's getting at is that depending on your condition, geospatially, you may have different fees, and further, if you, for example, meter your well and click that certified meter button when you're reporting, it could be less per acre foot. And you can kind of get my gist here. It's really complicated to calculate fees, and GEARS helps us. Next slide. Oh, yeah, digital signature, of course, this is critical. Penalty of perjury. Next slide. That's it. That's your success story of reporting. Gave you a big green check mark. This should be able to be done really quick, simply because once you declare your wells and parcels of use, you do not have to do it again, thereby getting to what the Water Data Consortium earlier was speaking about, in streamline reporting and making these efforts towards trying to streamline reporting. Next slide. This is an extraction report search. So what happened was all of a sudden the dashboard's different, the whole thing's different because this is the staff look. If we had, say, 10,000 or 50,000 reports, say we're in the year 2035 or something, and we've got thousands and thousands of reports, this is how you figure out where they are. You can search in any direction. It's not quite an ad hoc query, but every probable field we could think of. You can see I've made an example record, California Water Data Summit. That just shows that we can find the report we just did. And we can even flag it if we see a problem so staff can communicate back and forth in Gears about what the problem might be. All right, I think next slide. Okay, this is a geospatial version of the other thing. So that's an aggregated well distribution of fake demonstration wells that we have in Gears right now, just showing that staff can get to what they got to get to. All right, that's it. We can skip the rest of the slides.
Great. Thank you very much, Brent. The Water Board has a really challenging job with the fire hose of data that will be reported under SGMA. And I think a lot of us urban water folks can certainly relate to the need to streamline the state reporting processes. And it's really great to see your team innovating and working to improve the data collection and minimize the reporting burden and your ability to analyze that data. So Elena, let's put all of our speakers up on the screen. We've got just a few minutes for questions. So please use the Q&A feature in the Zoom to send them in. And while we're waiting, I'll start us off here. And I'd like to start with you, Brent. I'm sure there's some sensitivity about the privacy behind growers pumping data. And at the same time, we have a big push from the state to make water data more open to the public. So will Gears provide any data to the public under the Open and Transparent Water Data Act?
Let me make sure I'm off mute. Yeah, that's a fantastic question. So as far as like protocols for the Sustainable Groundwater Management Act moving forward, not my wheelhouse, but I can tell you that the way we built Gears was for that reason, so that the data could be shared if that's the decision that's made. The cool thing about Gears is we built it ourselves with a custom code base. So we own it, there's nothing proprietary, and therefore we have control over the data models. For example, if we were to provide Gears data to the public, it wouldn't be difficult to obfuscate names if we wanted to, or take other precautions to help people feel a little more comfortable with it being open. I would guess, according to 1755, that would be the case though, Lauren.
Okay, thanks. We've got another question for Brent here. This is from Vicki Englert. So for the Gears platform, how does the Water Board plan for and budget for ongoing developments, such as fixing bugs, new feature development? That's the first part. And then secondly, how do the water boards provide help desk support to pumpers and extractors who might have problems while submitting data in this application?
Excellent questions as I write them down so we make sure we follow up. The bugs and new features, so there's two sides to this. One is Gears before we are in production and at scale, which is the situation we're in now, at which we use SGMA discretionary funds to help build it as part of the SGMA program at the state board. So that before it goes live and goes major scale, that's the strategy. Now, SGMA also has a provision that says the state water board will collect the fees from the extractors necessary to implement the program. So long-term extractor fees that we saw would support Gears, bug or enhancement or whatever needs to happen. The help desk thing is huge. Right now, the strategy is that is a new sort of role for our groundwater program. And it puts staff in contact with the extractors. And so there's a neat benefit of having our own staff be the help desk in this sense. Now, when you hit that 10, 50,000 person reporter, we'll need to develop much more streamlined help desk style protocols, probably using like YouTube videos and things like that.
All right, well, I think that brings us to the end of our session. If you have other questions for our panelists, I encourage you to get in touch with them directly. Before we end, I'd just like to acknowledge Elena Hurst at Moulton Niguel Water District for running the show behind the scenes. She's the one making sure the slides work smoothly and that everyone's up on screen when they're supposed to be, and she's been doing a fantastic job. So thank you, Elena, and that brings us to the end. Thanks everyone for tuning in. Oh, and thanks to our panelists.
That was wonderful. Thanks so much, Lauren, for a great session, and thanks for the panelists. It was great to hear about all these different updates, and I know that we'll look for the future data summits to have a dedicated session on ag, because as you so eloquently said, there's a lot of other pieces to the water, to where water goes, and it's good to provide that broader context. And it's really, I think we in the urban space can also learn a lot from our partners in ag, and we're all the more that we all work together, the better. And it's really exciting to see all these different efforts. So with that, we have a little bit of a break, but before we do that, I just wanted to put up a slide to thank our sponsors again. Obviously, we couldn't put together this great event without our wonderful sponsors who help make sure that we have the resources and funding to support this two-day conference. So just wanted to thank Metropolitan and Molten Miguel Water District, Aquametric, BioLargo, Ratio, Synergy, Best Bets and Krieger, Flume, Geosyntec, Mazarine Ventures, PFM, and RDN. They're a big part of what went into this conference. And also, just to Lauren's point, just want to thank all the team behind the scenes who helping to make this all go smoothly, and really appreciate all of their help. We have a short break until 12:40, so grab some food, get some more coffee, some water, and we'll be back in about a little over 10 minutes for our lunch session from Clay from Flume. So thanks so much.